Here we go. Okay. So properties of logs. This statement right here is saying that the power of multiplication means that you add. The powers you get through multiplication is the same as if you just added the powers. The powers you would get through multiplying is the same as if you added the powers. The power you get from multiplying is the same as if you added the powers. All right, so that gives you intuition. I can prove this later. If you want to wait till after class, I can give you proof of why that's true using the mathematics of it, right? But intuitively, if you wanted to look at the power of a product, you could just add the individual powers. That's all we're saying. The power of division is just the difference in the powers. The power of dividing is subtraction. And then the power of something that's already a power is you just multiply the two powers. The power of the power is just the product of the two powers. Okay. So we're just restating these rules in terms of logs. And again, the big point of today is now, to answer my wife's question, is how are we going to solve and find the time it takes for that money to get to 32,000? And it's this one that looms large in order to solve that. Okay. I'll label these. Right, so this is the product rule for logs. The product rule, product meaning multiplication. Quotient rule for logs. For division, quotient means divide. And this is the power rule for logs. Power rule. Okay. I'll be using these. I'll be using that terminology to solve things. These are going to be useful in calculus because you're going to have something complicated, and when you take the log of it, it breaks it into two things that are much simpler sometimes. Okay. Let's do some examples. So here's some examples. What's the log of 2 plus the log of 5? Say it again. The log of what? That's the log of 10. The log of A plus the log of B is the log of A times B. So by the product rule, this is equal to the log of 2 times 5, which is the log of 10. But we know the log of 10. Log of 10 is 1. I taught pre-calculus over the summer at Carnegie Mellon University. Here's one that I gave on that test, their last test. I think it was, what's the log of 10 to the 10th? That's still 1. That's right. Log of 10 to the 10th. It's just the log of 10. And the log of 10 is also 1. Okay, let's cancel. You have 10, 1, 1. That's an aside. So these problems, these rules will be useful when you're expanding or condensing. The problem is going to say expand the following logs or condense the following logs. Okay. Here we just condensed. This was condensing. We took 2 logs and we made them 1 log, right? That condenses, right? So we can expand, right? So log base 3 of x, y. It's just log base 3 of x plus log base 3 of y. And again, in calculus, it'll be easier to deal with this, the sum, than it is the product, right, than 1 log. So, you know, expanding sometimes is super helpful. We'll raise the level here. What would this be if I had log of x, y over q? Log of x
plus log of y
plus log of y
minus
log of q. Right. Street version. Multiplication turns into addition. Division turns into subtraction. Not simple. Final thing we need is that all the powers go in front. Any power you would have would go in front. Right? So that log of x to the 7th, y to the 5th, over z to the 3rd, m to the 12th, turns into 4 logs. 7
log x plus 5 log y minus 3 log z 12
It's a minus
right.
12 log m. Good. Please.
Can you put that in parentheses and then make that a plus?
Of course. If I had said no, then you would need to have me fired. Okay. That's absolutely right. Yeah. Obviously, you can subtract the whole denominator. That's right. I don't know what my math lab's going to take. I think my math lab wants that. Right? They're both right, but again, as you all know, my math lab, it wants it the way it wants it.
Try that.
Right. So, yeah, that's right. So yeah, you can try getting it wrong the first time, right? But on the test, if the tests are in my math lab, it's going to want it the way it wants it, right? So say it again.
I'm sorry for the I would have a practice day, like a study.
Oh, yeah, practice.
If we decide, so we got to be fully honest. This is good. So I got a crew of people who had me for algebra, college algebra, who did it the way where we were in the lab and just grinding away the whole time, right? And what would happen, you know, is we would have assignments every day, people would work hard, and then the week before test, we would grind out a practice test that was very similar to the real test. And then, you know, so he's referencing a whole practice week, right? If we do things that way where we're labbing it up, which is fine, then yeah, we would have a practice week. The test would be in my math lab. We would practice them and all that stuff, right? So, yeah. But yeah, if we do it this way, then yeah, I mean, everything would be transparent. I mean, I would write the test, but it would be the same. It would be, I'm very transparent. The test would be just like all the homework, right? But so. Let's go the other way. Bring this back together. 3 log x minus 7 log y plus 6 log z minus 1/2 log w is really just the log of x to the 3rd, y to the 7th, z to the 6th, w to the 1/2. Or the square root of w, that's right. I could write the square root of w. Questions about expanding, condensing. Seems like this is, but we also have to recognize, I didn't say this, that again, most of college algebra ends here. So this is review for a lot of people, which is great. We'll just start off at a place where people feel comfortable and knock it out the park. I have no problem with that. Good to be on the same page. We can start to now answer my wife's question here. So when we're talking about solving logarithmic equations, now if we just solve 2 to the x equals 17, well, let's do 37. I want to remember that we said that x was log base 2 of 37, right? That's what we said. I'm going to start doing some things. I'm going to get something different. So what I want to do here is I want to take the log on both sides. What log you want to use, the natural log or the common log? Common log? Uh-oh. So that's fine. We'll use the common log. Take log on both sides. Again, my math lab may force us to do something else. So now I have log of 2 to the x equals the log of 37. Now what does the power rule allow me to do with this x? I can put it in front. Right. And this is the moment that we've been waiting for. That the x was in that power, and we were just like, well, wait, how in the world are we going to get that by itself? How are we going to get the x out of the power, right? When we have 3x equals 12, it's clear how to get x by itself. You just divide both sides by 3, and the x is there by itself. X at this point was stuck in that power, and now, not so shockingly, applying the inverse allows us to bring the x over, right, and now have it by itself, right? So by the power rule, I can then put the x in front. X log of 2 equals the log of 37. So again, all I'm utilizing, we'll do a recall. So just recall that log base b of a to the p is p log base b of a. Right? So you can just bring the power in front. Log base 10 of a to the p is just a log base 10 of, I'm sorry, p log base 10 of a. Now, as ugly as this looks, I don't care how ugly it looks. I'm solving for x. This is a number that's right next to it. This number is multiplying this. I need to get rid of this number. I do the opposite of multiplying. I divide both sides by this. X equals log base 10 of 37 over the log of 2. I'm sorry, go ahead. You're okay?
Yeah.
Okay. The great skeptic comes in and says, yo, hold up. I thought the answer was log base 2 of 37. Now you're telling me the answer is log 37 over log 2. Which one is it? Well, we know there's only one answer to this, right? And we know that that's the answer by definition. Did I do anything illegal here? No. They have to be equal. They're equal. Okay. So log base 2 of 37 is the same as log of 37 over log of 2. And oh my goodness. We should notice that I chose base 10. I could have chosen whatever base I wanted. Right? So log base 2 of, give me one moment. Log base 2 of 37 is log base 7 of 37 over log base 7 of 2. Log base 2 of 37, I could have chosen any base I wanted. This is how you change bases. Okay? So if you want to, so if someone likes being in base 7 and you like being in base 10, you can change from one base to the other, right? So we just demonstrated that log base 2 of 37 is equal to log of 37 over the log of 2. And in general, if you have, so this is called the change of base formula. And I don't think that this one is in, I don't know if this is in this chapter, in this section, or the next section. It might be at the end of this section. It's the next one, yeah. But it's relevant here. The change of base formula says that if you want to know log base b of a, then it's log base c of a over log base c of b for any c. You can change to any other base you want. So if b is a base that's funky, then you can always change it to a base we like and get the same answer. Right? So in the next section, they'll ask this. So then, for instance, for example, we can do log base 11 of 15. Right? I know that's a little bit more than 1. But if I wanted to know it to 12 decimal places, I would just take the log of 15 over the log of 11, or the natural log of 15 over the natural log of 11, both of which are in your calculator. You were going to say?
Can you still go ahead and subtract?
Subtract what?
2 from 37 to get a log 35?
Oh, no, this is good. Thank you for bringing that up. This, you would not subtract these. Let's look at the rule. The rule for subtraction is log of 37 over 2 is log of 37 minus log of 32. I'm sorry, log of 2. That's not, so this is not log of 37 over 2. This is the log of 37 over the log of 2. They're not the same. Is that okay? Yeah, they're not equal. So I wouldn't subtract those. Go ahead.
Well, can you just go back a little bit?
Yeah.
Can you briefly explain the thing again?
Here?
Yeah.
Right, so I want to find an x that solves this. Okay, I'm going to figure out what it is. So one way to solve it, to get this x by itself, now that I have this power rule, when I put logs on both sides, this rule allows me to bring the x in front, and then I can solve for it. All right. So this is the place we've been trying to get to, is how do the logs come in and help us solve and get x by itself, right? And so that now, when my wife wants to know how much time it is, then I'm going to say, okay, give me a few seconds. I need some paper, and I'm going to use some logs. And she's going to say, okay, I don't care. Just tell me the answer, right? But introducing so the street version is, when you have an exponential, you're going to be doing a ton of stuff in calculus, but you're going to get to a point where you have this left, and immediately you need to say, okay, I need to take the natural log. Okay. And I'm saying natural log because you'll be in calculus, and any other base you use, people are going to look at you like you're crazy, right? If you don't use the natural log. Okay. So, yeah.
So I still don't get what doing the log does.
Ah, thank you. So, applying the law gives you this on both sides, right? We are obsessed with getting this by itself. I want this by itself. This rule allows us to get the thing we're looking for in front, turning it into multiplication. So I'm dying to solve for this. That rule now lets me put it in front, and now I have it here, and I simply need to divide this away, and I have it by itself. That's the point. Good. Thank you for your question. I think we may be ready to hit it. We'll see if there's anything else extra in the homework. Log base 5 of 2 times 7. Write it. Expand. They're asking us to expand as log base 5 of 2 plus log base 5 of 7. That's all they know. They'll want us to simplify for the other ones, but that's why they went for this. Log base 6 of 6 plus log base 6 of x. They're not going to let us leave it like that. Log base 6 of 6? 1. Log base 6 of x. Go ahead, question. Log base 10 of 10 minus log base 10 of y. Right, so again, division turns into subtraction. Again, you can do the subscript by pressing shift minus, right? We're just going to roll through these, right? So this is equal to, this is division, the natural log of e to the fourth minus the natural log of 13. Natural log of e to the fourth, 4. All powers come in front. 2 log base t of x. We're not intimidated by this. The 12th root of x is just x to what power? 1 over 12. Right? So the natural log of x to the 1 over 12, you just bring the power in front. It's 1 over 12, the natural log of x. So roots, just 1 over that number. We're going to roll through all of these, right? Log, so 2 logs. Yeah. 7 log of y. Log base b of z. The square root is the 1/2 power. 1/2 log base 4 of g minus log base 4 of 64, which is 3. Is the power you raise 3 to? I'm sorry. Is the power you raise 4 to get 64? That's 3. We said that earlier. Division turns into subtraction. And just bring it all together. Log base b, 2 log base b of x, log base b of y, is b of z. Division turns into subtraction. Absolutely. Thank you. To 7, you mean?
Well, the 3 came from the 64.
That's right. This, what's the log?
Power.
It's the power you raise 4 to get 64. That number is 3. Two. Log of 4 times 25. Log of 100. 2. It's the power you raise 10 to get 100. Write as 1 log dividing. This is the log of 2x plus 3 over x. I think that my MATLAB has a root button. I don't think you need to use it. Natural log of the product of 2 things, y to the 1/4 times z. You don't need to write the times symbol. So 1/4. You could find that root symbol if you want and write the natural log of the 4th root of y, z. But nobody wants to do that. Addition turns into multiplication. Say it again?
I think they want it that way.
You think they demand it has to be this way?
Yeah, because it's simplified.
Yeah, but
It says simplify your
I
answer.
think it is.
they want the root. They're not going to take it as a fraction. Yeah, that enrages me. Yeah, that's right. Oh, you think we had this last semester, and you had to have the root? Well, test it out. I'm going to write an email about that. No, I'm going to protest that.
Is it going to be all in caps? Yelling?
Oh, that's right. It'll be polite. Those are nice people at Pearson. Yeah. All right, so natural log of x to the 4th, y to the 5th. natural log of the numerator squared the denominator to the 9th, right? So again, division turns in, I'm sorry, subtraction turns into division, and these are just powers, right? Oh, it's here.
Okay.
Yeah, it's here. I didn't think I was that crazy. Log base 18 of 16, right? So use whichever one you like, but this, they don't care which one you like, but you need to put that in, right? It's a natural log of 16 over the natural log of 18, or log 16 over log 18. They don't want you to put in either one of these. They want you to approximate this to 4 decimal places. It goes into the TI as ln parentheses 16 slash ln parentheses 18. So you can practice that. 4 decimal places. Should be slightly less than 1. 0.9592. Slightly less than 1. So that's the change of base formula we were talking about. Right? So again, anyone working in a different base can always go to their calculator. You can see from this that, you know, it isn't so hard to actually program any base if you wanted. But for some reason the programmers in the TI were just lazy and just didn't want to put in. Like I think like the super fancy ones, that one has log any base. That one is illegal in this class. But that calculator, it's okay. Unless you used it last semester, it's okay. Yeah. So, yeah, that one's way too fancy. Yeah. So. #16 word problem. The loudness can be expressed by comparing the sound's intensity to the intensity of a sound barely audible to the human ear. There's the formula. How can you rewrite that? I'm subtracting turns into division. I divided by I0. Which letter? Which letter? A, B, C, or D? It's D. It's D. And then they want you to plug in something. If the sound has an intensity of 100,000 times the intensity of a softer sound, how much larger on the decibel scale is the loudness of the more intense sound? Right, so can we express to the intensity of a sound? Okay, so of the softer sound. So if you have D equals 10 times log of I minus log of I naught, if a sound has an intensity of 100,000 times the intensity of a softer sound, how much larger on the decibel scale is the loudness level of the more intense sound? So then if you have I naught, then the other one is 100,000 times I naught, right? I'm sorry? 5? Maybe, right? So then this is 10, right? And then this is going to be log of 100,000 I naught minus log of I naught. And this is 10 times log of, you're going to divide, right? 100,000 I naught over I naught, which is 10 times the log of 100,000. And so 10 times the log of 100,000 is 10 times 5, which is 50. question whether is it 5 or is it 50. The sound has intensity of 100,000 times the intensity of a soft sound. How much larger on the decibel scale is?
So it's 50.
It's how much larger? It's 50 more than 0. That's right. Yeah, it's 50 more than 0. So it's 50. So the softer scale would be 0 decibel, and then this one is 50 times that. And the short version is that, again, this is how the log is helpful, right? It makes larger numbers more palatable. Please.
Like the last part, how does that translate?
This here, from here to here?
The next one.
From here to here?
Yeah.
Right. So 100,000 I0 over I0, the I0s cancel. And you're left with the log of 100,000. The base is 10. The power you raise 10 to get 100,000 is 5. And so that's also the problem, right? That when we do everything in 3 hours, right? I'm supposed to be pretending like we've gone over 2 days worth of stuff, right? And so all these steps I went through, I just talked about for the first time, for the first time a couple of hours ago, and I'm supposed to be like, remember, we just did this, right? But thank you for keeping me in check. Yeah. That is the game. We'll end there. I'll post this in just a second. They'll all be up. Link to the notes. Next week, we'll meet here, and then we'll walk over to the lab around the corner, and then the assignments will be open. We'll work on them in the lab. We'll see how we like that feel better or worse. Yeah. I should do that. I don't. But yeah.
Either way, they'll be up like this, and we can just.
Yeah. And I'll try to rename them when I do something important. Yeah. But you can give me a check, like name it.
Right.
You tell me to name it, I'll name it.
Okay.
Yeah. I'm gonna open it in just a few minutes. Yeah. Yeah. Tuesday at 11:59.